Okay, so this problem involves a river. And the thing about a boat on a river, it could be a kayak or a canoe or something, but the river flows. Okay, so, here the river is going this way. So, I don't know, the waves or the current. Anyway, the river is going this way. And that would be downstream. Okay, so it means the current on the river is moving the boat along. Okay, so here's a boat. I didn't take a lot of art classes. Okay, so the current of the river is helping the boat to go faster. Now, if the boat turns around, so here's my river still flowing this way, but say the boat is going this way. Here's my speedboat. Okay, and it's going there. The person's facing that way. He's going this way upstream. Now the current's going to slow him down because he's working against the current of the river. Okay? So that's the idea. I'm going to try to find a video to put in to help explain this, but when you're going downstream, there's a current that's helping you. Okay? So plus C for current, how fast the current's going. But if this is downstream. But if you're going upstream, then it's minus C. The current's working against you, okay? Because you're trying to canoe, you're trying to paddle upstream, and the current's pushing you back, okay? So the river current I'm representing with C. And it's an adding thing if you're going downstream, but it's a subtracting thing if you're going upstream. Now, the boat on its own has a speed, call it B. We say that's the speed in still water. So if there were no current and the boat were just, traveling on its own, power, it would have a certain rate. It would go so fast. It would go 20 miles an hour or something like that, okay? And that would be represented by B. So when you're going downstream, it's B plus the rate of the current. And when you're going upstream, it's B minus the rate of the current. So it's the boat minus the rate of the current. So let's say the boat in still water is 20 miles per hour. And let's say the current is 4 miles per hour. It's a really fast current. I don't really know. Okay. So if you were going downstream, you'd be going 24. So downstream, you'd be going 24 miles per hour because you'd take the rate of the boat plus the rate of the current. If you were going upstream, it would be 16 miles per hour because you'd have to do the rate of the boat minus the current. Okay, so I'm just trying to explain it. It's kind of tricky to understand, and it's going to be a very similar thing on the next problem when we do airplanes. Okay, so now we're ready to do the problem. A Mississippi riverboat cruise sailed 120 miles upstream for 12 hours and then took 10 hours to return to the dock. Find the speed of the riverboat in still water and the speed of the river current. Okay, a lot of times we set up a little chart for these. I'm going to put my chart here. I might have done this on other problems. Okay, so here's my rate, my time, and my distance, because it's still a distance problem. And then we're going to have the river's going to go up the stream, and it's going to go down the stream. Okay, so it says a Mississippi riverboat cruise sailed 120 miles. Okay, so that's going to be the distance, right? 120 miles. For 12 hours, that's going to be the time. And it's upstream. Okay, so it's the top one. Maybe I should color coordinate. Upstream, we'll make it in green. So 120 miles, that's how far. 12 hours, that's the time. And then, okay, we don't know anything about the rate, so we'll just kind of leave that blank. And then took 10 hours, so that's going to be another time. 10 hours to return to the dock, so back 120 miles to go when it was going downstream. Okay, so it was going upstream, then it turned around and went downstream. And it took less time, right? Because it's going faster downstream. So find the speed of the riverboat in still water and the speed of the river current. Okay, so you can use what we used when we were going upstream. You take the rate of the boat minus the rate of the current. Upstream, it's working against you. Downstream, you take the rate, you're going to go faster. You're going to have the rate of the boat plus the rate of the current. Okay? All right. So in the top equation, you're going to multiply the rate times the time. Fix this. You're going to go the rate times the time, and that will equal the distance. So the top equation is going to be written as v minus c times, that's not a c, v minus c times 12 equals 120. And the bottom equation is going to be b plus c times 10 equals 120. Okay? Now we can distribute in the top equation. So we get, I don't always do it this way, but 12b minus 12c equals 120. And then in the bottom equation, if I distribute the 10, I get 10b plus 10c equals 120. Now, I wish I would have just divided the top one by 12 and the bottom one by 10, but I'll show you that trick on the next problem. Okay, so we'll just continue with it this way. So I have these two equations, and I would like to add them together to eliminate something. I'm going to have to find an LCD, right, an LCM for 12 and 10, and I believe it's going to be 60. So if I multiply the top equation by 5 and the bottom equation by 6, that should work out for me. So now my top equation is going to say 60b minus 60c equals 1,000? No, that's not right. It should be 600. Yeah. We're multiplying here. Okay, that should be right. Now, the bottom equation, I'm going to get, and you might think, wow, these numbers aren't going to work out. But hold on. So 60b plus 60c equals, okay, what's that? 720? Okay. Now, let's add the equations together and see what happens. Okay, 60b and 60b, 120b. These cancel out. And I'm getting, let's see, 1320. All right, I'm going to divide by 120. Divide by 120. Oh, and what do I get? 11? Thinking I get 11. But I'm going to double check on the calculator. I don't want to lead you astray. So 1320, 1120. Yeah. Okay, so what does all that mean? It means the boat's rate in still water is 11 miles an hour. Okay. Boat in still water, 11 miles per hour. Okay, now we have to figure out the rate of the current, right? Okay, so you can just go to one of the equations. I'm going to go to the blue equation, and I'll show you kind of what I was talking about here. So I'm going to take this equation right here and say 11 plus c times 10 equals 120. Well, instead of distributing, I'm going to do a little trick here. I'm going to divide both sides by 10. You're allowed to do that. Those 10s cancel. And so you're going to get 11 plus c equals 12. And it just makes the numbers smaller and easier to work with. So you can see now, oh, c is going to be 1. You could subtract 11 if you want to, but c equals 1. So what does that mean? It means the rate of the current is 1 mile an hour. Okay, so river current, (1 mile per hour). Not a very fast river, probably. I don't know, I don't canoe a lot. Okay, so there you go.